All right. So what I'm gonna do is I'm gonna show you certain things first, and that way, have a building background, and I'm gonna show you demonstrations, so that way you can reinforce the visualizations. Most of you guys have no visualization skills just because everything's come in front of you now, and you don't have ability to visualize things, or spatial. They call it spatial knowledge. A lot of people just don't possess it, and just some people just cannot see. Especially some of you guys struggle in geometry. Yeah, and those are the people that have struggled with it. Spatial learning. With that being said, something. Um, let's talk about two different things that we are gonna do. One is called disk. And the one is called washer. So we are gonna focus on disk and washer on one day. Usually it's gonna be taught throughout a whole week, but we have one day to learn this. You have a test on Thursday? Okay, so let's start with disk. A disk method and washer method. And let's talk about different type of rotation. Okay, so all this is gonna be like very blurred, but later on we're gonna explain everything. So I know you guys have a lot of questions. Just wait until a little bit, then we can answer all the questions. There's different type of rotation. So different type of rotation. So first type is usually it's really easy. Is rotate around x-axis. Second type is rotate around y-axis. The third is the hardest one. Usually people struggle the most. It's called off-axis rotation. Now, um, does everybody able to get to off-axis rotation? No, sometimes show up. So I would say probably 30% of the time show up. On my test, yeah, it's 100%. But on AP exam, 30%. But most of the times around x-axis and y-axis, they're not very difficult. They not try to create a difficult problem for you guys. Me, in that sense, I do because I want you to understand all different kind of rotations. So they'll rotate around x-axis and rotate around y-axis and off-axis rotation. So you're gonna be like, wait, what does that mean? But I'm gonna write down everything else first. So let's start with disk. This method is basically a disk. So this is a disk. Okay, just imagine that if you have a quarter, that's a disk. Okay, so basically you find an area of the disk. Well, disk area is pi r squared. So disk is a circle, and circle is equal to area equal to pi r squared. What does that mean? Well, imagine that you guys know how to find the volume of ball, right? What kind of ball? Baseball, basketball? Pretty easy. There's a general formula for a basketball because it's a sphere. 4/3 pi r cubed, if you don't remember. Well, you should remember that one. 4/3 pi r cubed. Surface area is going to be derivative of that, which is 4 pi r squared. Are we okay? But a football, however, Do you have a geometric shapes that can tell you the volume of a football? Well, football is kind of hard, right? It's weird odd shapes, right? So, and then for me, I can't really come up with a formula, but I can give you a very good estimation of a football because football looks a little bit like oval, but it's not exactly like there's a point. The closest to the equation I can come up with is let's just say square root x. So y is equal to square root x. Do you guys know how to graph y equal to square root x graph? If you don't know, plug in a couple points to see. The point I will plug in is 0, 0, 1, 1, and 4, 2. And that's going to be this point. And I'm going to stop here. I'm going to stop here because I'm not trying to find a whole football. I'm trying to find half a football. If I find a half a football, I can find the other side as well. And I'm bounded by these three things. So the three things that I want to bound it is this. And here. And here's the axis rotation. Axis rotation is going to be here. It's going to be here. Now what we're going to do is we're going to design what is axis rotation. Now this is simple, you need to understand. This is how I draw them. I draw them like this. Like a curvy line, I rotate. So what I'm going to do is I'm going to take this graph. I'm going to rotate into the x-axis. So the graph is going to go outside the board, carve out, and it's going to rotation. What kind of shape am I forming? It'd be a half a football. Does some people have problem visualizing? No? No? Okay. That's good. I thought I need to help you guys visualizing, but basically this is gonna form like this. If I would draw it correctly, this is gonna draw like something like this. And this is gonna be like this. This after rotation. So then you're gonna have something like this. But what's the cross section here? What is the, if I cut off here, right? If I cut off like right here, what kind of shape am I forming? Like if I cut a slice like vertically, what kind of shape am I forming? It's a circle, it's a disc, right? So this is where I'm gonna show you the demonstration because I thought like usually it's fun to think about those things. So I like doing stuff like this. So I'm gonna show you that.
Is this why you want to sit next to me?
No. When somebody don't show up to the next test, or if you fail the AP exam, you know what happened.
I didn't bring my safety goggles today, Mr. Yan.
So, yes, it's not legal for me to bring a knife to school. I don't give a shit.
Live streaming with Steve.
Yeah.
What?
It is the watermelon.
Okay, so I have a watermelon. Um, All right, so I need some paper towel. Paper towel here. Okay, so for me, later on we're gonna talk about other stuff. So we're gonna start with the building block, so that way you can see. So there is a reason why I draw that outside boundary is green and inside boundary is red. So to show you what it look like. So what I'm gonna do is I want you to see this. This is what I want you to see. Sure. Okay. So this is a disk. So here I can even record it. I can record you. You are the star of the show. Okay, so this is the disk part. This is the pi r square part I'm talking about. But they are see the pi r square as I'm going inside, right? The pi r square is getting smaller and smaller. Radius is getting smaller, right? And this is the 0, 0 part. Do you guys see that? So the radius is almost 0, close to 0 there. So what I do is I always show student the rotation. I thought it's always interesting to let students see this because this is where the axis rotation happens. And Mr. Ye is really good with knife.
Maybe put one cutting on a flat surface.
Yeah, I usually borrow cutting board, but okay. So anybody want watermelon? Some people say yes. Okay, sure. Okay, so what I'm gonna do is I'm gonna take only a single slice. Okay, only a single slice, yes. Take this.
Mr. Gay, I'm glad you're not teaching culinary.
Well, huh? Maybe he'll do a better job than I can. Yes, but he's not gonna do a better job than me on next part. Unless he. Eating the watermelon? No, I'm missing a joke. Okay, so I'm gonna take a drill bit. I'm gonna drill into watermelon. Hopefully it will work. It must be a weird thing you see people do. They click it?
You have it tilted.
I have? Okay, so now it should be fine. Okay, so now so now what we're gonna do is we're gonna drill this. Okay, so as you see, this is a rotation we need, right? So you guys see this? Okay, so this is gonna be a rotation. So this we call axis rotation. So you're rotating this to form this your circle. What are you guys laughing at? Why something funny? So I'm gonna show on camera so that way they can see. Okay, so it's rotating here this way. So each thing slice, this slice here is gonna form a circular disc. So what happened is you're gonna add the disk of infinite amount of disk from here. Instead of area, we adding infinite amount of area. In this case, we're gonna add infinite amount of the disk from here to here. We can cut that disk so tiny small, and we just add them all up. So we can find a volume of football, a volume basketball, a volume of football, a volume of watermelon, or a volume of vase. If you think about vase, right, it has really weird shapes, right? We found an equation based on that shapes. That's gonna be using regression. If you're using regression, you just rotate them, because every cross section, if you look on top of base, it's all circular. It's different width of a circular. Okay, so different radius of a circular. So you're basically just adding each individual part. So does that make sense? So yeah, so this is actually very good. So I'm gonna put it down. And so that just to show you what it is. And then we're gonna go back. We're gonna look at here. So we're gonna not end stream, but go back. Where's my iPad go?
You should put that as like the group chat. Your boss.
Where's my iPad go? Okay, computer screen. All right. So what we did is we take this, and this looks like this. Your chopstick is your axis rotation, and you're rotating around here, and you're rotating inside and outside to form the disk, an infinite amount of disk. Are we okay here? Okay, so now later we can carve out inside here. We can cut off this part here, and we can rotate again, and that becomes a washer. So let me see if I can arrange this. I know it's kind of messy, but oh well. We'll live. Okay. So we have discovered this method. And this method is going to be pi r squared, but a little bit different, right? Because we got to add an infinite amount of disk. The adding of the disk part is the integration part. So then this method, we can evolve this. We can evolve this. We know that is pi is the constant. The integration between two values, in this case, will be 0 to 4. Is that okay? Because we stop at 4. We don't integrate before, like the 4 is the highest radius we can, the 2 is the highest radius we can go, because square root 4 is 2. Of the function r of x squared dx. But in this case, what is my r of x? What do you think can represent my radius? Which function can represent my radius? Chris knows. Anybody else? Which function can represent my radius? Which function do we have? Square root x, yes. Because square root x, think out if this is 1, then you're going to have a radius of 1, right? If you think about this is 4, then you have radius of 2. So you basically, that square root x is the distance from the x-axis to the function, for the center axis rotation to the skin of the watermelon. So therefore, that's going to give you this rotation. So therefore, in this particular case, that's going to be equal to pi integration 0 to 4 square root x squared dx. Wow, this is simple integral. Square root x squared, yes.
Why do we square, or is that just how you do it?
Why do we square? That's a good question. What's area of a circle?
Right. Okay, never mind. Thank you.
Good job. So pi r squared. So r needs a square. You cannot just have an r. It's not pi r. Does that make sense? So therefore, as integration of 0 to 4, and everybody can do this. This one just going to be pi times integration of 0 to 4 x dx, which is x squared over 2. I think between 4 to 0, pi, and that's equal to 8 pi. And we just find the value of the shapes. 8 pi, what is that, inches or whatever, right? 8 pi square inches, right? So square inches or whatever. That will be a value. Volume of half. Okay, so but we only based on this rotation. So if you want to find a volume of football, whole football, it'll be 16 pi because we double it. So there you go. That's this method. Bless you. So let me give you a general formula for disk. So a disk, in general, is going to be pi a to b of r squared of x dx. The r of x is defined from center of rotations, from the center of rotations, from axis rotation to the boundary. Okay? So that's the radius. Now sometimes you can have a same graph, right? You can have same graph, but rotate around y-axis. So imagine if you have same graph rotate around y-axis, and that's different. So, but sorry, you have if you have a disk rotate around y-axis. So this is called a vertical disk, and you got horizontal disk will be pi. Now instead of a to b, I'm going to categorize as c to d because sometimes boundary is different. If you go into y, remember that question 2 was negative 16 to 16 for x. For y is 0 to 4. So we're going to categorize this as c to d. And sometimes we're going to have function in terms of y. So this is going to be r of y squared dy. So this is a general formula for disk. Huh? Yes. So there are two types. So you have a disk, right? You can have a disk. Now you can have a washer. You're like, wait, what is a washer? Well, washer is not like washing the clothes washer. Like that's what Sava does, right? Washer is like when you have a tool, like the rings, like when you have a screw and you have a tool like this ring. So that's called washer. And usually about this big, you can tie up the screw much easier. It kind of like stabilize they don't flap back and forth. So those are things that you have to understand. That's a washer. A good representation of washer is actually pretty interesting. We're going to think into this in a second. So a washer method is based on the area of the bigger circle subtract the smaller circle. So imagine if you find an area of this. Okay? And normally people don't get confused with this. I'm going to show you which one is, and you're going to decide which one it is, okay? So here we have a big R. We're going to call this big R. Here we're going to call this small r. Okay? So if I want to find the area of this region here, you're going to tell me which one. Whether it's r minus r squared or r squared minus r squared. Which one is the right answer? This is a very, very confusing for a lot of students. It's the first one or the second one? Joshua, what do you think? Nicole, what do you think? Astrid, what do you think? If I just want to find the area shader region, which is the outer ring. Katie? Emily? This is a good SAT question, right? Caroline? Natalia? The second one's correct. Because you want to find out a bigger area of the, so if you distribute this, that's going to be your bigger area. And you carve out what's inside. But if you look at the difference, that becomes the area of probably like something like this. Rather than the ring, but the inner. Because you take the difference, right? You take a bigger minus smaller, and you look at this, so it will actually be the inside. Gabby, does that make sense? So imagine 1 is 5, 1 is 3, right? If I do 5 minus 3, that's going to give you the difference. That's subtraction. And then you're going to form a ring based on that radius. Does that make sense? So that's why this one is not correct. So in order to form a Washer method, you really need a base on this formula. So a Washer method is going to be integration of a to b pi r square of x minus r square of x dx. And the second one, it could be a horizontal, c to d. Remember, they can do different value. Pi, and then it's going to be r square of y. That means function in term of y. So you could have x equal to y plus 2 or x equal to y squared, just like what we did yesterday, minus r square of y dy. And put a parenthesis around here if you want to, because usually in decimals, you need another parenthesis there. What does this mean? This means, hey, I decide to use this shape. And I don't want to rotate as a disk. And I decided to say, well, I want to cut off one part of function. So we're going to cut off that one part of function. We're going to take it off. Like this. We're going to cut off this function. And this is going to form a circular cone if you just think about a hollow part. If I just spin the hollow part, it's going to be a cone. So be watermelon, take away the cone. I don't know if you know what I'm saying.
Could it be different shapes inside?
It can be different shape. It can be like a curved shape. It can have any shape. So, but if you form a circular, it's going to be a bigger ring with watermelon and a small ring without watermelon. So you're taking the bigger ring, subtract the smaller ring without watermelon. So you carve it out. You take this knife, you cover a cone outside the watermelon. So it's going to be that kind of shape. So it's hard to visualize. And so I don't have a way for you to visualize through here because it's kind of difficult. So it turns out that Desmos has this link that I can send you if you want to, is to help you visualization. Solid revolutions. Let me see if I can find a better one. Like this. Okay. So this is square root of x. And then so some of you guys said, oh, okay, well, if I'm looking at this, what does this mean? Well, I'm going to change this a little bit. I'm going to change this to that. And I'm going to change the view a little bit, just a tiny bit. So this is the graph that we know, square root of x graph. Now, if I change the view, tilt it a little bit so that way you can see, and then you can see the rotation. So you can see the rotation that is gonna form the football shape or the bullet shape. Does that make sense? Is that okay? So each one is a disk, right? Now I'm zoom in so that way you can see it. Do you guys see this or no? That's the rotation. That's the disk, right? Now, what if I have a different function? So you see that f of x equals square root x, which is the function that we know of. Can I just change to another function? Just say, hey, I want to have, I don't know, 1/2 x. Something like this. So now I'm going to carve out a cone. And you're not going to see this, but at first you see only a ring outside. But if I cut it forward a little bit here, you see that there is an inner ring and outer ring. Because the inner ring is formed by 1/2 x. So I can carve out. So let's say between 0 to 3, let's say between, we're gonna do not do 0 to 4, 0 to 3, that we're gonna have a ring there, and this is a ring that we accumulate. We accumulate different kind of ring from 3 to all the way to 0. It's because we want to carve out a cone inside. And so if you look at different perspective, then you probably see the ring clearly. Do you see that? That's the ring. And we're trying to accumulate all the ring from 3 to 0. I'll take a breather. You guys okay? I know there's a lot of like expansion of the mind, but okay. So this is washer method? Yes. What does a corn dog look like?
On a stick with bread around it. You've never seen a corn dog?
Well, he doesn't eat meat.
Oh, fair enough.
I'll show you a photo.
We're gonna do that.
I know your 7-day adventures, so I know your question. We can share a recipe.
I'm gonna show you the eggplant lasagna.
What do you got?
I love eggplant lasagna.
Yeah, because if you cut it,
You mean just the outside, but on the inside, not the hot dog part?
yeah, it like if you imagine like the
Just
hot
take out the hot dog?
the inner circle, yeah.
Yeah. Okay. Yeah, you can see that. Yeah. No, it's fun. It's really help you visualize if you think about those shapes, because we're gonna think about a lot of shapes. So I'm gonna give you a lot of hints. So here's is my idiot-proof way to find any disk washer. Like you can be as dumb as rock like me. I have developed a system for like 15 years, and I'm trying to perfect it so I can teach within 1 hour and people can understand. But it requires you to follow very, very specific rules. So the first thing, so this is an idiot-proof way to find even off-axis rotation though. So, but you have to be able to draw it correctly. So pay attention on your drawing skill. Your art skill really matter now. So first thing is I'm gonna tell you says always draw the graph. Draw the bounded graph. Draw the bounded graph. Why is bounded? Because sometimes you bound it, you need to see that bound. Okay, bound the graph correctly. So that's the first thing. If you draw it, great. Second things I want you to make sure that you do, which is very, very important, is draw the axis of rotation. Okay. Draw the axis rotation. So what I did, I draw axis rotation right here. This is a good axis. So I decide the axis. If they told you axis, I'm gonna draw axis rotation based on that particular part. Next one. 3. This is probably the one of the hardest step to follow, the way you draw it, okay? But you have to pay attention from where to where. So you want to draw, and I'm gonna put a keyword from axis rotation axis rotation to the boundary or boundaries. Okay, draw from the axis rotation to the boundary or boundaries. Usually it's either one boundary or two boundaries. The axis doesn't count as a boundary, by the way. So sometimes, you draw sometimes the axis count, sometimes the axis doesn't. But just the boundary, you can see the bounded graph, you can see the boundary. Okay, so if you have one boundary, that means this is a disk. If you have two boundaries, that means a washer. This is a very easy way to tell. Let's go washer. But you have to draw from the axis rotation. You cannot draw from the boundary to the axis rotation. You have to be a specific orientation from axis rotation to the boundary within the A and B or within C and D. 4. This is an easy step. Decide dx or dy. Dx usually is a horizontal. No, sorry, vertical. Dx usually is vertical. And dy is usually horizontal. 5th. Now, if it's dx or dy, if it's dx, you gotta use function in terms of x. If it's dy, then you gotta do it in terms of y. Your function should be everything y, not x with dy and y with dx. So you want to make sure you solve for that functions, right? So if it's y equal to x squared, then it could be x equal to square root y, right? So it could be either or, but you have to depends on the dx dy. 5th thing, decide the boundaries. Decide the boundaries, which is either A to B or C to D. C to D, right? C to D is going to be this is the x, this is x orientation, this is the y orientation. Y is from here to here or from here to here. That's why we'll take an integral. 6. Okay, so depends. If today is a washer, so today is disk, correct? If today's disk, then you have to figure out what is r of x is, or r of y. If it's a washer, then you have to decide what is r of x and r of x, or r of y and r of y. So those two different radius, two different terms. So if it's a disk, then you have to decide what is r of x, or 7. In order to complete this integral, don't forget certain things. Don't forget pi is in the front if you have rotations. Don't forget the pi. Joshua, pay attention. Don't forget pi. Don't forget the boundaries. Don't forget the dx or dy. And don't forget the squares. Because you have r squared. So like what Alejandro says, why do we need a square? Some people forget that square. Sometimes you have a square and square. So you cannot forget the square, the dx, dy, the boundary, the pi. That's all the things you have to double check before you finish your integrals. Last not the least, this one is very, very crucial for people to understand. And it's really hard to understand. And this is what's the most challenging part is. If you have a y equal to or f of x equal to, that is the distance from x-axis to the functions. If you have x equal to or f of y is equal to, that means distance from y-axis, usually it's from the axis to the functions. And this is gonna break. It's a breaking point part. This is the part that most of people struggle. And this is the part that you have to draw it. Make sure correct drawing. It will help you solve the problem. Correct drawing will solve the problem. So what we're gonna do is we're gonna make sure we're gonna go back to this. So start with this. We're gonna start with this the textbook questions, and we're gonna go through different rotation. Hopefully you understand. So we're gonna do all different kinds. You gotta decide what is it. Make sure you follow the 7th step and make sure you observe the last one. The last one's the distance. Understand the distance is very, very crucial. If you don't understand the distance, that's gonna be a problem. So I'm gonna show you example understanding distance. Let's just say if I have square root x like this, right? Which is the one we just did. That's the one we just did here. So this distance here is given by the functions because this is the f of x equal to square root x. Does that make sense? Now I can have this way. What is this distance? This distance from here, this is actually f of y. And that's f of y is equal to y squared. Why? Because y equal to square root x equal to y squared. You can square. So this is the distance from here to here, from this point to this point. Always from the axis. Always from the axis. Very, very, very important to help you solve the problem. So now we're going to give you a question for you guys to practice. And there's 4 different parts, and we're going to go through them all. Okay? So 8, 7, 6, 7. Okay, so the question is going to start with y equal to square root x, and y equal to 0, and x equal to 3. And we want to, first, we want to rotate around y-axis. So the first thing is I want you to rotate around y-axis. Can you do this one? Or shall I guide you? Because we already kind of teach you how to do this one. Because the one we did is 0 to 4, but this one's just a little slightly changed. Rotate around y-axis. So I'm going to follow all the steps, okay? And I'm going to show you how to follow the steps. But I'm going to let you try it first. First, draw the boundary. So it's going to be from 0. But it's not to, it's to 3. So it's going to be here. So it's around right here, right? Did you draw this graph? Okay, did you draw the axis rotation? Hello? This is Mr. Yang from Olympia. He's absent a lot, and he hasn't. Okay, but even he, but even if like when he was playing well, he's absent a lot as well. He's doesn't do his work and also doesn't show up to school. So I think this is the last few months. So I need him to able to. I mean, I understand if he's not feeling well, but most of the time it's just like he's not showing up. Okay, yeah, let me. Yeah, and I talked to him already several times. I don't think it's getting to him, so you probably can talk to him. Okay, thank you. Okay, so now did you draw axis rotation? Did you do this? Okay, so now I'm gonna draw from the axis rotation. Make sure the way you're drawing, it's gonna be from here. Make sure you draw it from here to here. Has to different orientation. Not from the boundary to the axis rotation. Has to be from axis to the rotation because it matters. It matters a lot. You have to draw from this point to there. Now, since this is vertical, is that dx or dy? Yes. Oh, is it? Sorry. Oh, I mean x-axis. Sorry. I'm so sorry. I screwed up. It's x-axis. The first I read it y. So and we're gonna do the y-axis later. So that's the next part. So, did you draw that? First of all, drawing has to be done correctly. Is this dx or dy? Dx, because it's a small slice of dx. So you're gonna start with dx. That means your function has to be in terms of x, right? Functions in terms of x, right? So you don't have like y, something y. So from what boundary to what boundary? 0 to where? 0 to 3, good. Okay, so what else we had to decide? Decide boundary. Is this disk or washer? It's this because it only draw to one bound, right? So if it's one bound, then that's a disk. So then now you're gonna find your r of x. If it's disk, then it's gonna be r of x. In this case, it's square root of x. So that's gonna be integration of 0 to 3 pi square root of x squared dx. Second part, we want to rotate around y-axis. So now we're going to rotate around y-axis. Now use the same drawing. Now something need to be modified because your axis rotation is not in the same axis anymore. And the things that you get might not be the same thing. Yes, Joshua. There's something else need to change. There's lots of things need to change. I don't know, but go ahead and change it. Go ahead and do that. Yes. Right now, don't worry about the evaluation. We're gonna worry about the setup first. Like I say, I will give you answers, and you can check your answers. That's more important. Evaluation is after you get a right answer, then you go back to evaluate. Because you gotta learn how to do the integral. Some of you guys still not good at calculation, arithmetic, and stuff like that. But start with setup first because I don't want you to get frustrating getting not the right answer because sometimes it could be just the wrong setup. And you work on the wrong setup, there's no point. You waste 10 minutes, you waste a lot of time. Okay, did you guys draw this? Okay, let's try to draw it together. So if it's gonna go in from here to here. Now this is a boundary, right? Now axis rotation is where? The top, right here. Did you draw that? Did you draw that notation over there? That's the axis rotation. This is my drill. My drill is sticking chopstick through there. Okay, first of all, what kind of shape am I gonna forming? No, it's not a donut. Huh? Not really. What kind of shape? What kind of things that remind you of that? No, that's not donut. Donut's not flat outside. It's not cylindrical.
Upside down volcano.
Do you guys know the bun cake? It kind of looked like some kind of bun cake. Yeah, but inside, yes, the inside is like carved in like this, right? The bun cake.
Do they have a name for that kind of shape?
No, there's no name for that shape, but it's like it's cylindrical outside. So you take a bun cake, you take a ring, and then you take out all the extra parts, so you have a cylindrical outside. Inside is the bun cake, like inside is like this. I never had bun cake before in my life. I just heard about it. I just see them. Maybe you can bring it on a pie day, right? Lucia, are we doing something on a pie day?
No, we don't go to school that day. Are you breaking it? Oh, 3, 4, 6.
It's not Friday. I thought it's Friday.
No, it's a Friday. We don't have school though.
We don't have school on Friday.
No, it's a teacher work day. Like,
Yeah. That's why Thursday's our last day.
Thursday's also the book day. So Abid will be administering the test.
All right. So now what we're gonna do is we're gonna have this. Do you see? I draw from the axis rotation. Do you see how I draw it? How many boundary do you guys see? So it's a disco washer. It's a washer. Okay, so I'm gonna show you two different lines. One is this one, right? And one is the purple line all the way here. So that way I know this is a washer because it's two line, because it had two boundaries. Because you gotta worry about the purple line, which is the cylindrical shapes first, and you have to worry about the carve out shapes, which is the red line. Yes.
Why do you turn your boundary from y equals?
I just want to pick between 0 to square root. Okay, so because I want it between A and B, I don't want it outside. Okay, so now I have two lines. Is this a washer or disk? Okay, so it's first of all, are they dx dy? Dy, right? Is this okay? This is a washer. Good. And from what boundary to what boundary? Be careful. From what boundary to what boundary? No. 0 to what? 0 to root 3. Why is root 3? Because you want to make sure that this is equal to this, right? So you got to plug in 3 into here to find out is it stopped right here. You want to find out where this point is. This point is going to be root 3. How do I know root 3? I plug in 3 into the functions. So be 0 to root 3. Is that okay? So I have dy, I have washer, I have 0 to square root 3. What else? What else do I have to decide besides that? R of, so it's a washer. So washer, then we have two different things. R of y in this case. What is R of y? Who says? 3 is correct. Y is 3. Because the length all the way here is always 3. Is that okay? And how about small r of y? Anybody else? Charlotte? Small r of y, the red line.
For like that specific red line, or
Yeah, that specific red line. I'm trying to help you.
like 5.
Astrid? Not always one is changing. Emily? Katie? Rohan? This small red line right here, I'm interested. This red line can change, depends on where it is, depends on which value is. So Rohan? Charlotte? Y square is correct. Can you explain to everybody why is y square?
When you change the function of y is equal to square root of x to in terms of y, x is now equal to y squared, which is that definition of it.
Does she make sense or still doesn't make sense? Catherine, does she make sense? Okay, so remember this phrase right here, right? If I ever have x equal to, that's the distance from y-axis to the function. This is x equal to y squared. That's the distance from y-axis to the function, y squared. Yes.
How did we get the square root 3 from the first section?
Because I plug in 3 into this, so I know where the y value I stop. So that is integration, right? Don't forget pi. If the rotation is always pi, 0 to root 3, is that okay? What's the big R? What's the big R here? 3. And what is small r? And don't forget what? Square. You gotta put a parenthesis and square. Parenthesis and square. This is already square, but I still have to square again. And then dy. Don't forget dy. Then you're done. Okay, we're gonna do the next one. Now this one's kind of challenging. This is called off-axis rotation. We want to rotate at a line x equal to 3. Okay, so first of all, tell me, think about it by yourself first. Don't rely on other people. Are they joy first? And decide, are they disc or washer? Think about what kind of shape would it be. Think about, are they dx or dy? Think about the boundary. Think about if it's a disk, then it's big R, what is R? If it's a washer, there's a big R and small r, what is it? And then come up with an equation. So rotating at a line of x equal to 3. Now this is known as off-axis rotations. This is where the challenge part today is off-axis. We're gonna do a few until you get master at those skills. Don't worry, we will get most of the third period get it yesterday. We still have a lot of time. We still have 30 minutes to expanding your brain, even though your brain is probably kind of tired.
It's a wash.
It's a wash. It's a wash. Oh, you say this is a washer? I don't know. I don't know if the washer or disc, but you gotta join. Use join. This is effort. That's what I'm trying to say. Don't just sit there and look at me, because you cannot sit there and look at me and get a result. You actually have to put some effort in to do something. Even you drew it wrong, even you did it wrong, that's still effort. Think about what kind of shape does this look like. about a drill is over there and it's taking that shapes and rotating around the axis. Think about what shape will they look like. Bless you. Guys, what kind of shape does this look like? What? And Nasir, what'd you say? It does. It does. No, you said something else. What did you say? That's not half a sphere. No, that's not half a sphere. Hamburger bun is really accurate. That's a really nice job. Hamburger bun. Is this a disc washer? It's a disc? Okay, we'll see. Did you guys find the equation? So this is axis rotation. Do you see this? This is the axis rotation. And that's gonna form that hamburger bun as Ignacio was talking about. I'm hungry now. What?
You don't eat meat.
This is a veggie burger. Yeah, it's Morningstar. I would do Morningstar. Morningstar is good. Go to Publix. They have a lot of time BOGO. Buy one get one. Do you run out of choice of food? Okay. No, Morningstar they make good veggie chicken products. Subway has a very good veggie patty. It's actually like the people who there. She's like I always eat that because I actually taste better than me. Okay, so I'm gonna draw it. Did you guys draw it? Did you draw from the axis rotation to this way? Now this is where people mess up now. Okay. So you draw from there to there, right? And you say, okay. And I must say, probably nobody got it right here. And there's a reason why nobody got it right. So is this dx or dy? Dy, so write it down, dy, right? Boundaries from where to where? 0 to √3, good. Is a disc a washer? Disc. Okay, so then we know we're gonna do integration of this from 0 to √3 and the pi, and we know there's r of y. Now, here's the hard part. Who's very confident about the answer r of y? Chris, yes?
3 minus 1 squared.
Did anybody got different? Alejandro, what'd you get? How'd you know your answer is wrong? You didn't even tell me yet. What is it? God damn it, tell me.
No, I erased it.
Well, tell me before you erase it. No, you write down something. Tell me what you write down.
No, because I just had it in the wrong terms. I just put in dx instead of dy.
Okay, then you gotta tell me that. Gabby? Natalia?
I got y squared too.
Charlotte?
Too.
So Lucia? Tell me your wrong answer. God damn it.
I want an answer.
Joshua?
Do this, but I should change the boundary from like 3, like change my 0 to like 3. So like the other side, like push the other side and do it.
No, you don't want to stretch that situations. That gets very, very dicey. Rohan? Alejandro? Gabby? Asher? Asafa? Nicole? Charlotte?
Put it out there. Would it be square root of y?
That would be no. No. But that's okay. It's a good try. Okay, so 2 people are right. One's Chris, one's Nicole. Very good job. And the things about why that is, right, is the black line I'm interested. So pay attention how I draw it, okay? How do I get a black line? I'm going to draw an extra line to help me. There is a purple line. The purple line is always what? 3. And there is a function. Function is given by the red line. So it's a purple minus red. And purple red is y squared. Because if I solve y equal to square root x, x equal to y squared. So this is a y squared. So it's purple minus the red is equal to the black, which is black is something I'm interested. Good job, Nicole. Good job, Chris. How many people are lost? Raise your hand. Okay. Do you see this is something I'm interested? But y squared is giving from here to here. It's a red. It's not what we want. What we can do is using the red and use the total length here. We can subtract them to get this right here. So it'd be 3 minus the function. 3 minus y squared. But your drawing has to be precise. This is an art skill here. And I'm not a... Katie, give me a look that you should not teach art. She gave me that side eye. I saw it. You don't think I see it. I see them. Okay, so now we are rotating around line. X equal to 6. This one's kind of hard too. Learn how to draw. I really like this lesson, but I don't want to do 2 more times today. Anybody want watermelon, by the way? Chris, like, yeah, sure.
Yeah, I'll
I
take
had a
it.
question too.
Huh?
I had a question.
You have a question? Okay, go ahead.
If we should have 6
He
or
pulls the
is
ice
this
cream
You
watermelon.
know, like how the
No, you gotta decide that. Are you talking about part D?
yeah. Like, is there free rope?
Are you part C or part D?
You watched that knife mystery.
I don't know. I guess. If you die, it's not my fault. You didn't get
Yes,
food
it
from me.
is. Look at the. You put the knife on the drill bit. That's so disgusting.
You know what? You
I'm
will
gonna
be
be poisoned.
alive.
No, like your immunity builds up when you like eat dirt. Did you know that?
Don't drip on my floor.
You only get
Huh?
Is it super
The floor is what?
Just the floor is super clean.
No, because it goes in bed. No, what the? No, but you're not rotating around your base. You're rotating around 6. Time continues.
Why is this so far away?
You see, if you die, it's not my fault. You did not get a watermelon from me.
I'll take some.
You know, my dad would be like, "Oh, she got a pass. Hold that. Don't. Let me show you what I said.
It doesn't make sense. He cut off the watermelon and it
Don't trip on my foot, though.
I'll
Then this of you with like no context, right? And he goes, "Look at 3D integrals. Like, why are you such a nerd? Why do you say that?"
I don't know.
I think that me and your dad can hang out and become best friends.
Yeah, I think it's good. Wait, Mr. A, are we keeping our rotation around 3 or is it now just 6?
6.
Okay.
Does the line go to 6?
It's draw from the axis rotation.
The same.
Draw from the axis rotation.
Is there not gonna be like a giant hole in the middle?
This one?
Oh. It's like a donut for like
Hamburger, but like
yes, circle. Already in.
Like a bagel, maybe?
The big
Almost like a bagel. Yeah, so it's not a curving part.
Yeah,
It's not, yeah.
hamburger bun, and then you put a cookie cutter in the jam. Hamburger bun, like you put like a cookie cutter in the middle.
Yeah. Cookie cutter.
You see, I understand what it looks like. I understand how to make the equation, but it's calling it.
Whoa! 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 Charlotte, what's your language?
You're like, it's 3, now it's 6. It's like, a lot of probably got the watermelon in here.
What? Yesterday, I bought it yesterday. Yesterday. You'll be alive, trust me. I'll bet my money Lucia's gonna be alive by yesterday, and Charlotte will be alive.
Yeah, I needed food from Pakistan. I think I'm fine.
That's true. If you could, I mean, if you can survive India or Afghanistan, then your stomach is built of iron.
I had to get a tetanus shot because I fell on the street.
All right, so did you guys draw out? So 6 is right here, right? This is the axis rotation. Did you draw this? Did you draw this? Did you draw that axis rotation? Okay, did you draw in specific orientation from axis rotation to the boundary? It has to be that way. It has to be that way. So it has to be, well, there's one line here. Is that okay? And there is a second line from here to here. Okay, so are they dx or dy? Dy, good. So the function should be in term of y, that's automatic. What's the boundary? 0 to radical 3, okay, good, that's good. Is it disc or washer? washer. So washer, that means there is a R of Y and an R of Y. So what is a big R of Y here? Be careful. What's a big RY? Okay, no, I don't want to ask that first. I want to ask what is small RY first. I'm gonna call on people. What is small RY here? Ignacio, what do you think?
Would it be like the radius of like the smaller circle from 3 to 6?
Which is what?
Isn't it like 9?
I think you think too complex. Gardet, what do you think? What's small RY? Just look at a distance. Look at a green line. What do you think that is? 3. Yeah, it's just 3. It's just 3. Because that's the distance from there to there. You can look at it. That's why your drawing's very, very important. You look at a drawing. Does that make sense? Okay. Now here's the hard part. R of Y. Let's see how many guys can get this. I know Chris and Nicole should have no problem with this one. I need to ask other people. So, Wary, what do you think? What's a big R of Y here? 6 minus Y squared? Does everybody agree with Wary or no? That's a good question. So, what do you say, Natalia?
You have to take out like the center.
Okay, so what we're interested in the purple line, right?
Yeah.
The purple line is constantly changing, right? It could be a little bit longer here, but still based on a function. So what we can do is we can take this from here to here. That's going to be 6 units. But take away the function. The function is going to be the brown part. And that's Y squared. So in order to get purple, it's always 6 minus a function.
What happens when it goes like above that?
It doesn't, because your integration is from 0 to √3. You stop by √3. That's a good question. No, that's a good question, because you stop there, you don't go anything further, so you don't have that issue. Yes.
I may just like retweaking, but wouldn't the Y squared be the inside part, like this part of the curve?
The Y squared is from here to here. It's the distance from axis to the function. You look at this definition here. X equal to is the distance from y-axis to the function. That's why I write that down to show you guys. This is the distance from the y-axis to the function. You guys got it? Okay, let me give you another one. Let's see if you guys can handle it. Rotate around. Y is equal to 7. Rotate around y equal to 7. Your homework is doing the second page first, because second page is more like rotation. The first page is actually FRQ for the things. So they're a little bit challenging. So start with the things that you're familiar with. The answers are posted on the second page. So rotate around y equal to 7. Now this one I'm gonna let you guys go through with each other, see if you guys got the same thing. But off axis is the hardest thing that you're gonna learn in terms of volumes. Yes. No, we're not gonna do that. That gets kind of tricky. That usually Calc 3. No, because that's Calc 2. The x-axis depends. Sometimes x-axis can be a boundary, but in this case, I don't think so. Oh, x-axis, yes, it can be a boundary. Yes.
What's that one?
Around y equal to 7. Okay, around y equal to 7.
It's like this, right?
I think if you cut it in half, you can have it.
Okay. Maybe half. It's the inside of famous. Wait, what was it? Hold on. It's really hard, right? And then it's like a hold on. Let me say it. It's kind of like a really weird tilt. It's like the really like
It's kind of look like
it's like the
inverted.
so it's like the or the outside of like
The boundary is square root 3?
I said I don't think it is.
I don't think so either. For this one, around y equal to 7? No. It has a natural boundary.
Mr. Ye, whenever it turns on the y-axis,
This is not y-axis. This
No,
is
yeah,
y
but,
equal to 7.
like it's always dy, and then
So depend on the line you draw. If the line you draw is horizontal, it's dy. The line you draw is
so it's
vertical.
always the same.
No, the boundary should be.
Monday we're gonna do cross sections, so make sure you show up that day too. And then Tuesday, Wednesday is pretty much. Now, if you need to take a test on Wednesday because you're not staying here on Thursday, you can as well. But I will prefer you take it before the break because otherwise you're gonna forget it. Can I go over it now? Okay, so y equal to 7. So this is the graph that's gonna be here. Stop y equal to 7. 7's right here. Sorry, 7's the other way. 7, 1, 2, 3, 4, 5, 6, 7. 7's like this. So this is this line and this line. So this is a dx. This is a washer. And this is a 0 to 3, actually, not root 3. So it's going to be 0 to 3 pi. The big R is going to be 7 squared. The small r is 7 minus the function, which is square root x squared dx. Next one's still period, right? Because the y, this is the square root x. So 7 minus root x.
Here's the things I have to do. Like turning in a prom guest board and turning in a project. Well, my 4th period teacher will be that, but she'll later.
No, my
So I'm gonna go do that now and then come back here and run the class. Italian.
50 minutes.
Literally, it's something that my people were like, I bet he'll almost say, he's like, I'll do that.
One of the previous ones, when
for this one, when we had the SC56, there's no other boundary. It's just this one.
Just because you integrate from here to stop at the square root.
I just know that we would never
You don't
see
need
him
to do
again.
root 3 to 6 because that has no relevance. You're not rotating past that.
So I'm just doing just this.
It's
Because
actually from here to here.
No, but last week at
It's
the
from
end
this
of
point to this point. This where the lines
I'm gonna
stop at square root 3.
I'm gonna
All of us on the line stop at
But how about like this
It
open
doesn't
part?
matter because we're looking at a Y perspective. So we're looking at only this region, not this.
came back from Kansas.
Okay. Is the homework what you posted yesterday?
Yeah, second page first.
That's what I'm doing. There's no way it's escape. But yeah.
I did it because you can't really do it.